Hello and Assalamualaikum to our panelists and viewer for my presentation. This video is in purpose to present about my final year project 2, MEC602, with project title of Study of Wear and Friction on Implant Materials using pin-on-disc testing. Hello, my name is Ameer bin Azmi and I will be the presenter of the video. My supervisor is Mohamad Mazwan bin Mahat. Please enjoy my video. Project summary. This project study on wear and friction of implant materials of cartilage replacement with lubricant. It is conducted using pin-on-disc testing. The lack of data on knee implant studies, notably on wear behavior linked to discomfort, instability and stiffness after a lengthy time of usage are the intention for this research. Study on polymer material for total knee replacement biomaterial. What is cartilage? Cartilage covers the end of bones of tibia and femur in knee joint as we can see on this figure. The motion of knee in daily activities can cause wear to the cartilage, and it is known that cartilage has limited repair capability since it is a flexible fibrous tissue. Thus, knee surgery is required if the cartilage has worn out or damaged. The demand for cartilage replacement is increasing year by year. Problem statement. Forces acting on the knee due to daily activities can worn out the knee cartilage. Polymer can lead to wear due to constant force sustained constantly. Patients that facing knee injury and the medication treatment is not helpful. They need to perform total knee replacement surgery. The material for total knee replacement need to choose according to suitable of mechanical properties for implant material on human joint. Based on the previous journal, the lack of study and data on wear rates of polymer as material implants brings to this research. For scope and limitation, the result obtained based on structural parameters for wear rates using wet testing pin-on-disc. Parameters chosen based on previous study or journal. Stainless steel used for pin and 3 types of polymer used for this. Literature review. This is my top 5 article research. Most of the article search is based on the pin-on-disc testing. Besides that, articles based on material and lubricant also have been used to help conducting this research. For total knee replacement (TKR), there are about 400,000 total knee replacements carried out by the surgeons in the United States of America annually. Total knee replacement is acknowledged by orthopedic surgeons for being the most effective treatment in order to improve function in pathologic knees. It also has unexpected early wear as well as revision of arthroplasty. Knee surgery is the best method to heal the wound of cartilage because the chances is very low for cartilage to regenerate. Tribology. The science of tribology is the study of the interaction between two moving surfaces. Tribological principles have been extended to comprehend the loading environment of dilateral joints, despite the fact that it is traditionally associated with the study of non-biological materials. Pin-on-plate tribological test method with simple geometry have been widely utilized in the research of tribology of cartilage. Similarly, the test methods have been adapted to evaluate the tribology of potential cartilage biomaterials. Material. A biomaterial is any material that is used to replace the function that mimic to human body tissue and continues in contact with the fluids in the human body. It also performs enlarge or replaces a characteristic capacity to improve the quality of life of the patient. It also refers to materials that will be in direct contact with the tissue, cells, and bodily fluids in the human body. It equilibrizes for defects caused by aging, illness, or accident. In the course of recent years, biomaterials have been developed with multiple forms of implant and medical devices in replacing the function-degenerated tissues of human tissues. A lot of attention has been given to biomaterial for the past decades. In the United States, up to 13 million implantation devices were implanted annually. As you can see in the figure, is the requirement of implants for compatibility, mechanical properties, and manufacturing. Methodology. The first one is project flowchart. The figure shows the whole process of the project from this preparation until collecting data analysis, theoretical study and literature review on material, lubrication and pin on these theories from various paperwork, journal and book has been studied to understand the basics in performing pin on this testing. Next, the material for this were determined as a result from theoretical study and literature review. ABS, PLA and TPU disc preparation. 3D printing machine used to make ABS and PLA discs based on properties of SolidWorks drawing is necessary to follow the shape and dimension, then transfer it to Ultimaker Cura in STL format to adjust the pattern and density of this model. The drawing is then uploaded to the Ultimaker Cura in STL format to adjust the infill density and pattern of the disc model. 100% infill density and lines pattern are used for models which only require to print 20 layers of filament before completely turn out a perfect 70 mm diameter with 4 mm thickness of this model. Stainless steel preparation. This experiment uses 316L stainless steel with length of 6 meter and 8 mm of diameter. Then it was cut onto 25 until 30 mm length and same diameter. The length and diameter based on the specification of pin for pin on this testing. The grinder was used to cut the stainless steel about 10 cm each and then cut onto 25 until 30 mm by using abrasive cutter. Abrasive cutter was used to ensure the cutting is more accurate measurement and smoother surface finish. After that, the steel needed to grind and polish so that the surface finish is smooth. The surface finish needs to have smooth mirror finish so that the wear result for the experiment is more accurate. Results and discussion. The time taken for each experiment is 30 minutes to avoid any risk occur to osteoarthritis. The speed follow the cycling and walking activity. 3 speeds chosen based on the mostly recommended knee rehabilitation program, which is cycling. 67.5 kiloloads are fixed boundary condition for this experiment due to the average weight of people with osteoarthritis. This is to study the effect of wear and friction occur on ABS, PLA and TPU discs. Effect of load applied on material wear. The wear performance graph was used to analyze the wear of material used. On initial stage of experiment, the wear rate is higher due to the adhesive nature of the rotating biomaterial disc. The graph shows two regions representing the steady state and running periods while the experiment is running. For the steady state period, the wear increased linearly with the sliding time and increased at a considerably slower pace. On the other hand, the wear rate in running periods increased very rapidly as the sliding time increased. The result for TPU disc shows that negative wear rate due to the material TPU itself. TPU material has high flexibility and the stainless steel pin stands to compress the TPU disc before starting the experiment. Once the experiment started, the pin will go to its normal position, which is higher than the starting point. This will show the negative wear results. Besides material, the low speed also affecting the negative wear rate result. The best speed range for running experiment is between 100 to 2000 RPM. Based on figure below, the wear rates for PLA disc is too small due to lubricating factor and load is too light. The lubricant can affecting the experiment results become inaccurate. Effect of load applied on friction force. The development of the friction force during pin on this test at room temperature is shown in figure. Due to the superficial layer of the pin was the first time in contact with the disc, the friction force is minimal early in the rubbing process. The value grew, however, because the pin required larger pressures to cut through the layers of the disc and because of the ploughing effect, which roughened the disc surface. When comparing the speeds of 360 rpm with the other two speeds, the graph shows that higher speeds yield higher friction force. This figure shows the graph of friction at 90 rpm. Based on this figure, TPU disc has the maximum frictional force because they were formed from a melting liquid that was placed into a disc mold to solidify. As a result, it created a harder disc structure than the other two that were 3D printed layer by layer printing. The increase in shear force and frictional thrust was accompanied by a rise in the wear rate value has been accelerated due to the applied load. As the sliding speed decreased, the frictional heat decreased the material strength and high temperature, which result in increased adhesion force with the pin. This indicates that the contact between the pin and the disc at this period of time was already reached the steady state. Furthermore, the steady state condition is due to the surface roughness and other parameters able to be attained at a short period even though there is an increase in the normal load. Comparison on wear rates. This figure shows that ABS has the highest value of wear compared to PLA and TPU. On the other hand, Nadia's result shows that the value of wear for ABS material is between 500 to 2500 micron. For the present result shows that the wear for ABS material is about 150 micron only. The present result is lower than the Nadia's result is because the lubricant factor that affect the value of wear for our experiment. The Nadia's experiment using no lubricant, which is dry testing for pin on this testing. The result for TPU material for both method is negative due to the flexibility factor of the TPU material. PLA material is the lowest and least wear received for both method and experiment, which leads to the best material for cartilage replacement. This is the graph for PLA wear versus time at 90 RPM, present versus Nadia. As a conclusion, the results obtained for this study is the wear rate of polymer disc. PLA is the material of choice for biodegradable implant design and use in the clinic. Researchers present a brief description of the use of PLA as a biodegradable material for various implanted devices, as indicated by the numerous patented concepts. The cartilage replacement with the lowest wear rate, according to the study findings, is the most suited. The most suited implant materials for cartilage replacement is PLA due to the lowest wear rates compared to ABS and TPU. The three samples tested with speeds of 60, 90 and 360 RPM for PLA wear rates as the value on the screen. As a result of this research, manufacturers now have the option of using polymer instead of metal to replace cartilage since it is less costly and simpler to get. Recommendation: in the future research, we can make the pin on this machine custom that can achieve more speeds and sustain more load since the current pin on this machine on your ATM only provides certain speeds and loads. Find the most suitable substitute for synovial fluid to mimic the knee movement. Find more sponsors to buy more expensive material for this research. Thank you everyone for listening, and I hope you guys enjoy my presentation. If you guys have any question, do not hesitate to contact me at 1.ameer911@gmail.com, or you can contact me at 012-604-7541. Thank you.